Okay, so today we are going to look at number 27 from the free response. So let's see what we got here. Okay, so the rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time t equals 0, when the bird is first weighed, its weight is 20 grams. If b of t is the weight of the bird in grams at t days after it's first weighed, then we have this function that represents the rate of change of the weight of the bird. Let y equal b of t be the solution to the differential equation with the initial condition that at time 0 the bird's weight is 20 grams. Okay, so let's look at part A. So part A is asking, is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Explain your reasoning. So they're asking about the rate of the change of the bird's weight at 40 and 70. So this is our rate of change of the bird's weight. So what they're really asking is, if you were to look at dB dt and evaluate it when b equals 40, or I'm going to copy and paste here to cheat a little bit, I would take this, let me erase that. I'm going to use this one. My pen crashed earlier when I was recording this video, so that's why it looks the way it does. That's why I had this in here. Okay, anyway, let's backtrack. So they want to know between these two things here, so between this and this, which value is larger? Because whichever value is larger is going to represent the faster rate of change. So let's take dB dt and evaluate it when b equals 40. So evaluating when b equals 40, I get 1/5 times 100 minus 40. So 1/5 of 60 is 12. I'm then going to do the exact same thing, but I'm going to evaluate it when b equals 70. So I'm going to get 1/5, 100 minus 70, which is, so that's 30, 1/5 of 30 is 6. So 12 is obviously larger than 6. So the baby's gaining weight faster when its weight is 40 grams than compared to 70 grams. So let's put that together as a statement. So what I'm going to do is I'm going to take these two things and I'm going to say, hey, look, this is bigger than that, right? The rate of change when it's gaining 40 is greater than when it's gaining 70. I've already shown my work. So, and my conclusion is, therefore, the bird is gaining weight faster when its weight is 40 grams. Okay, let's move on. Okay, so it's gaining weight faster when its weight is 40 grams. Okay, so what do we got next? They want us to find the second derivative and then use that second derivative to explain why the graph cannot resemble the graph that's shown. Okay, so we want to look at the second derivative. So let's see here. So for this one, we were given the first derivative. We were given our differential function dB dt equals 1/5 100 minus b. So now they're asking us to take the second derivative. So second derivative time. Okay, so let's see. This is 1/5 is a constant, so I'm going to take the constant and multiply it by the derivative of that 100 minus b. So this is going to be 1/5 times the derivative of that stuff. So the derivative of 100 is 0. The derivative of negative b is actually just negative dB dt. Next, I want to put this thing right here. Let's show you guys in orange. I want to rewrite this in terms of b. I don't want this in terms of dB dt. So the nice thing is they gave us a function and they told us right here what dB dt equals, so I can replace it. So I get 1/5. Actually, if you don't mind, I'm going to pull that negative out. So the negative 1/5 times dB dt, which is 1/5 100 minus b. So that gives us negative 1/25 100 minus b. Okay, so the question becomes, how do we know that when we look at this function that we've just calculated, how do we know that the graph they gave us is wrong? So let's look at the graph. I'm going to quickly grab it so we can look at it. Okay, so let's think about what the second derivative talks about. The second derivative is all about concavity, right? So it tells us about the shape. So if this is our graph, if this is the graph of our b function, right? Time versus weight. This is the graph of b. We should be looking at the concavity because that's what this thing tells us. Well, what does this tell us? So if we were to look kind of at our, let's look at our kind of our values for b, our possible values for b. So our values for b, we're going to go from it. So it starts at a weight of 20, right? They told us at time 20 it equals this. And if you notice, I'm going to just kind of look at this value for b here. So I'm going to end it at 100. Okay, so looking at that interval from 20 to 100, if you were to plug in any number from 20 to 100, right, into the function that we've got. So for example, if I were to do a test value and I were to say d of b dt, and I were to evaluate this at, let's say, b equals 80, I think you'd agree I'd get negative 1/25 times some positive number. I'd get a negative value. In other words, from 20 to 100, this function is supposed to be concave down, but the function is clearly concave up. Therefore, the graph is incorrect. So what I'm going to say, on the interval the derivative, the second derivative, right? Oh, I'm just going to write, how about we just be more specific? dB, whoops. Let's write, use proper denotation. So the second derivative is negative. But the graph given actually, I'm going to rewrite that just slightly just to be a little more specific. So it's negative, which means, right, I'm going to interpret what that means. So it's negative, which means it should be concave down. But the graph given is concave up. I'm going to just be on that interval. I don't think that's not a big deal, but just feels better to me to say that. Okay, so let's just quickly review. I took the second derivative and I said, okay, second derivative talks about concavity. I saw that the whole thing was concave down when b was basically less than 100, but the graph given was concave up. Therefore, we had an issue. So the graph had to be incorrect. Okay, let's move on to letter C. Use separation of variables to find y equals b of t, the particular solution to the differential equation with the initial equation b of 0 equals 20. Okay, so this is a separation of variables thing. They're very nice to just kind of say, tell us what we're supposed to do here. So I'm going to say d of b dt equals 1/5 times 100 minus b. And also, just kind of note, right, this thing goes to the point 0, 20. At time 0, it is 20 grams. That's our initial condition. So let's go and integrate this. So before I do that, I'm going to do a little separation of variables here. So I'm going to say dB over 100 minus b equals 1/5. Equals 1/5 dt. So now let's go and integrate both sides here. So the left-hand side, just kind of note, I'm just going to you may already see it, but if I let u equal 100 minus b, then du equals negative dB dt. So in other words, negative du equals dB. Sorry, I don't know why I'm using the wrong notation. Equals negative dB. Okay, so just kind of note that it's going to be negative. So in other words, if I were to go and integrate this, it's going to, using u substitution, it's going to look like this. Okay, on the right hand side, I'm just going to go through and integrate it, and it's just going to be 1/5 t plus some c. So cleaning up the left hand side, this is a natural log, so this is going to be negative natural log, and u in this case is 100 minus b. And again, that equals 1/5 t plus some c. Now, we want to solve this for b, so let's see what we can do here. Let's get rid of that negative, so I have natural log of the absolute value of 100 minus b equals negative 1/5 t. Quick reminder, a c, because it can be positive or negative, it's not going to, I don't need to change its thing. I'm just going to write down some other thing just to show that they're not exactly the same. Again, not a big deal, but it doesn't need to change sign there. So let's keep on going here. So now I want to get rid of the natural log. So I'm going to get the absolute value of 100 minus b equals e to the negative 1/5 t plus some c. Doing our exponent rules, I get absolute value of 100 minus b equals e to the negative 1/5 t times e to the c2. I'm going to let e to the c2 just equal some, let's just let it equal k. It doesn't matter. So I'm going to say, I don't think I have to show this, but just for you guys, I'm going to say e to the c2 equals some k, or just some c if I want to. But now I can say 100 minus b equals k e to the negative 1/5 t. Let's solve this for b. We're getting very close there. So negative b equals negative 100 plus k e to the negative 1/5 t. So b equals 100 minus k e to the negative 1/5 t. Okay, now let's start plugging in our given initial conditions. So I've got my general stuff, but I needed to plug in at time 0, the bird's weight is 20. So I get 20 equals 100 minus ke. Negative 1/5 times 0 is 0. So this is going to be 20 equals 100 minus e to the 0 is 1, so just k. So I get negative 80 equals negative k, which means k equals 80. So my final equation, right? My final equation is b equals 100 minus 80 e to the negative 1/5 t. Okay, let's just make sure. I want to check and see if they were asking any domain questions or anything like that. Use the separation function. They don't ask for it, so we should be fine there. You could, if you wanted to say, this only occurs when t is greater than or equal to 0, right? Because t can't be negative because it wouldn't be born yet. So I don't think we need to put that, but I'm just going to put it here because it just seems to make sense, because this is not, the domain is not clearly not all real numbers. Okay? Okay, anyway, Actually, if you really wanted to be specific, this function probably only works based on what they said. It only probably works from when it's time 0 to when it hits adult weight. But is 100 the adult weight? It seems to imply, the function implies that it's 100 is the adult weight. So we could say from 0 to 100, but I think saying t is greater than or equal to 0 is fine. Again, we probably don't even need to include that. I think the big thing that we need to include is that that is all they're asking for. Anyway, I'm rambling here. So anyway, that is our lesson today. That is our that problem today. I thank you as always for watching, and I will talk to you next week.